Hello everyone. In this lecture we will discuss artificial variable techniques of simplex method, and I am going to discuss two-phase method using one example. So let us start this example. Here the problem is of minimization. Minimize z x1 plus x2, and these are the constraints. So first we have to convert it into standard form. So this is minimize z, so you can convert it, you can write it, let z dash equal to minus z. Now you can convert it into maximization, so you can write maximize z dash this equal to minus x1 minus x2. Now if you see the constraint, this is greater than equal to, again this is greater than equal to, so you will use surplus variable. So you can write on adding surplus variable, surplus variables, say s1 and s2 we get. So equations can be written as 2x1 plus x2 minus s1 is equal to 4, x1 plus 7x2 minus s2 is equal to 7. So now we have to check whether we can get initial basic feasible solution from this stage or not. So number of equations 2, number of variables 4. So 2 variables are extra variables. So if we put x1 equal to 0, x2 equal to 0. So we will get s1 equal to minus 4 and s2 equal to minus 7. But if you see, if you write the corresponding matrix, this is 2, 1, 1, 7, minus 1, 0, 0, minus 1. So this is the part of matrix corresponding to S1 and S2, and this is not a unit matrix. It means we cannot consider this solution x1 equal to 0, x2 equal to 0, or s1 equal to minus 4, s2 equal to minus 1 as an initial basic feasible solution, because this is not a unit matrix. The matrix corresponding to the basic variables must be a unit matrix. ध्यान रखिएगा, यहाँ पर ही हम इसको डिसाइड कर सकते हैं कि हमें आर्टिफिशियल वेरिएबल की टेक्निक्स में जाना है या नहीं जाना है। अगर ये जो आपके यहाँ पर, जब आपने इनिशियल यहाँ पर ये रखा था कि x1 इक्वल टू 0, s2 इक्वल टू 0, तो हम ये s1 इक्वल टू माइनस 4 एंड s2 इक्वल टू माइनस 7 आपको मिला। लेकिन s1 s2 के करस्पॉन्डिंग जो यहाँ पर ये मैट्रिक्स है, this is not a unit matrix. So that's why you cannot solve it using ordinary simplex method, because for ordinary simplex method you need this as a unit matrix. So हम क्या कर सकते हैं, what we can do, we will use artificial variables. तो हम add करेंगे on adding artificial variables. Artificial variables say a1 and a2. इक्वेशन क्या बन जाएगी, 2x1 प्लस x2 माइनस s1 प्लस a1 दिस इक्वल टू 4. सेकेंड इक्वेशन x1 प्लस 7x2 माइनस s2 प्लस a2 दिस इक्वल टू 7. एंड यू कैन राइट x1 comma x2 s1 s2 a1 a2, all these are greater than equal to 0. Now from here we'll check whether we are getting initial basic feasible solution or not. Number of equations 2, number of variables 6. So 4 variables are extra, so you will assume let x1 equal to 0, x2 equal to 0, s1 equal to 0, s2 equal to 0. Then what we will get, a1 equal to 4 and a2 equal to 7. So here you will see the part of matrix corresponding to a1 a2 will be unit matrix, because this is plus 1, this is plus 1. Now you can say this is the initial basic feasible solution. So यहाँ तक तो आपको डिसाइड करना है कि क्या हम आर्टिफिशियल वेरिएबल टेक्निक यूज कर रहे हैं या ऑर्डिनरी सिंप्लेक्स मेथड से आप यूज करेंगे। अब हमारे पास दो मेथड है। फर्स्ट मेथड इज artificial. First method is two phase method. Two phase method में basically two phases are there. In first phase, we are going to find the initial basic feasible solution for the original problem. Look at this. This is the original problem, this one, and this is problem using artificial variable. Artificial variables केवल artificial variable हैं. Artificial का मतलब केवल हमें इस problem को यूज कर रहे हैं कि सॉल्यूशन हम निकाल सके. So you are using these artificial variable to just get the initial basic feasible solution. Now in two phase, the first phase will be utilized to find the initial basic feasible solution for the initial problem. जैसा कि हम क्या कर रहे थे, अगर ये -1 नहीं होता, यहाँ पर पहली प्रॉब्लम में -1 नहीं होता, तो हम सीधे ही जो हमें सॉल्यूशन मिल रहा था कि x1 0 x2 0 और s1 यहाँ पर अगर ये नहीं होता, माइनस नहीं होता, प्लस होते, तो यही में इनिशियल बेसिक फिजिकल सॉल्यूशन मिल रहा था. लेकिन क्योंकि यहाँ पर ये माइनस माइनस है, इनका जो मैट्रिक्स बन रहा है ये -1 0 0 -1 है, ये इनिशियल बेसिक फिजिकल सॉल्यूशन नहीं है. तो इसलिए हमें अलग से इसका इनिशियल बेसिक फिजिकल सॉल्यूशन निकालना पड़ रहा है. तो जैसा हम पहले में डायरेक्टली मिल रहा था वो हम निकाल रहे हैं यहाँ पर. सो दो फेजेस यहाँ पर हैं, फर्स्ट फेज एंड second phase. In first phase, what will we do? In first phase, we will try to find the initial basic feasible solution for the original problem. And how can we do? For this, we have to consider the function, objective function, maximize z for phase 1. For phase 1. Maximize z equal to two artificial variables are there. So this function will be minus a1 and minus हमेशा इनको माइनस में लिया जाएगा. यू विल कंसीडर इट इज -a1 and -a2. नो नीड टू टेक x1 x2 and other variables. Simply this function is maximize it -a1 -a2, and these are the constraint, or you can say equations. So considering this as an objective function, these are the constraint. You have to solve this problem as simply ordinary simplex method. Okay, so now come to this table. So this is the ordinary simplex table. Here the basic variables are, look at this, these are basic variables, these are non-basic variables, non-basic variables. So you have to make the ordinary simplex table as I have already discussed in previous lectures. So these are the coefficient. If you look at this, this is, now in this objective function is this here. This is not z, but you can write z dash. Maximize z dash because we have changed z dash. So -a1 -a2. So no x1 x2 s1 s2 are there. So simply these coefficients are, you can write 0 0 0 0. So this is -1 and -1. Clear? So here again the coefficients of a1, this is 0, this is not 0, you will write it not 0, you will write it -1 and -1 because coefficients are -1 and -1. This is -1 and -1. So remove this 0. This is -1 and -1. Now xb, the value of the a1, a2. Look at this. This is 4 and 7. So you can write it. This is 4 and this is 7. Now x1, x2, all these you can take these values from here. So this is 2 1. This is 1 7. This is 1 7 -1 0 0 -1. This is 1 0 0 and 1. Now we have to calculate z dash in the same way. This product of cb xb -4 -7. This is -11. This is the value of z dash, and here you will calculate zj. For this one again cb x1 minus cj. So -1 into 2. First I calculate this first value, this -1 into 2 plus -1 into 1 minus 0 minus 0. So this becomes -2 -1 -3 -3 minus 0. This is -3. So this value is -3. Similarly, if you calculate this second value, this is -1 -7 -8, and this value is -1 into -1 plus 1. This one 0. So this is 1. Again this is plus 1, and this is, look at this, minus 1, this is 0, minus 1 minus 1, this is 0, and again this is 0. So these are the values of z, j. Now apply the same rule. One, at least one value is negative, it means this is not an optimal solution. So you will choose the most negative value, this is minus 8. And to decide this, now x2 is incoming vector. To decide outgoing, we will calculate the ratio of xb and x2. So this is 4 divided by 1. 4, this is 4 divided by 1, ratio of xb, x1. All these are positive, so you can calculate the ratio. This is 4. 7 by 7, this is 7 by 7, this is 1. This is the pivot element, and A2 is outgoing. So we have to repeat the process. Now, so here I have written this previous table number 1. So this is the pivot element, this is incoming vector, and this one is outgoing vector. Now look at this, x2 is going to take the value of e2. It means x2 is replacing e2. So we have to make it 1 and this one is 0. So we have to form next table. So say suppose this is R1, this is R2. Now what are the rules for R2? So R2, look at this is 7. How can you make it 1? Divide it by 7. So this is R2 divided by 7. Now look at this. Here in the next table, the basic variables are, this is A1, A2 is replaced by x2. So here I have written x2. Now what are the coefficient? For A1, this will remain minus 1. For x2, coefficient of x2, now look at this, in the objective function only A1 and A2 were there. So that's why the coefficient of x2 will be 0, because only A1 and A2 were there. Okay. Now from here onward we will calculate. So divided by 7, so this is 1, this is 1 by 7, this is 1, this is 0, minus 1 by 7, this is 0, this is 1 by 7. Now for R1. So R1, this is 1 and this is 7. It means what we have to first divide it by 7, then we have to, you can write it, if you divide it by 7, this will become 1. So easily we can subtract R2 from R1. So the rule will be R1 replaced by R1. This is 1 minus R2 by 7. It means first we have to divide it by 7. So it will become 1. Then we have to subtract it from this 1. So R1 replaced by R1 minus R2 by 7. Or you can utilize the new row. New row means this is already R2 by 7. It means you have to subtract this old row from this new one, because this is R2 by 7. So 4 minus 1. So 4 minus 1, this is 3. 2 minus 1 by 7. So if you calculate 2 minus 1 by 7. So this is 14 minus 1 by 7, that is 13 by 7. So here it is 13 by 7. Similarly, 1 minus 1, this is 0. Minus 1 minus 0, this is minus 1. And look at this, 0 minus 1 by 7. So this is 1 by 7. So 1 minus 0, this is 1. This is 0 minus 1 by 7. This is minus 1 by 7. Okay. Now we have to calculate z dash. Z dash is CB, XB. So minus 3. This is 0. So this is minus 3. Now the new value of z dash is minus 3. Now we have to calculate ZJs. This is CB XJ minus CJ. Here you can write it 0, 0. You can write it 0, 0. You can write it 0, 0. You can write it 0, 0, 0, 0, 0, 0, minus 1 and minus 1. So Zj, now look at this, minus 13 by 7, this is 0, so you can write it minus 13 by 7. So this value is minus 13 by 7. Similarly, if you calculate, this value is 0 and this value is 1, minus 1 into minus 1 plus 1, this is 0, so this is 1. This value is minus 1 by 7, this is minus 1 by 7, minus 1 by 7, this is minus 1, and again you have to substitute minus 1, so this is 0, so this is minus 1 multiplied to minus plus 1 by 7 plus 1 by 7 plus 1. So this is, look at this, minus 1 minus 1 by 7, so this is 1 by 7 minus 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 1 means plus 1. So this is 7 plus 1, 8 by 7. So this is 8 by 7. Now if you see some negative values are there, it means it is not an optimal solution. So the incoming is the most negative. So this one is incoming, that is x1. Now to find the outgoing, we have to find the ratio of xb and x1, xb upon x1. So 3 divided by 13 by 7. It means we can write it 21 by 13. This one is 1 by 7, so this is 7. Obviously this one is minimum, so this is minimum, it means this is the outgoing and this will the pivot element, 13 by 7. So here I write all this here. I have written already these values here in this table. So this one is outgoing, this one is incoming. Now we have to make the table, we repeat the same process and again you have to make the next table. So here I have written all these values in the next table. I will write here the rules. What will be the rules? Look at this. If you write, say this one is R1, this one is R2. So what will be the rule for this one? You have to make it 1, x1. Now this will replace a1. So this will become 1. So rule for R1, this is 7 by 13 R1. Means you have to divide it by 13 by 7. So or multiply by 7 by 13. Now rule for R2, this is 1 by 7. Look at this is 1 by 7. It means we have to make it 0 with the help of this one. So we need to make it 1 by 7 so that this becomes equal to this one. So it means you have to divide this by 13 only and you have to subtract it with this one. So you can write R2 minus R1 by 13 only. So R1 minus 13 means this will become 1 by 7. So if you subtract, then this will become 1 by 7, this will become 1 by 7. So if you subtract these two, this will become 0. So these are the rules. So if you apply these rules, you will get this table. Okay. So the same table is here. Look at this. The same table is here. Now here if you see, value of z dash is 0 because now the basic variables are x1 and x2, their coefficients are 0. Now look at this, previously in this table the basic variables are x1, x2, coefficients are 0, 0. So same table is here in this case. So z dash equal to 0, cb xb 0, 0, 0. This is 0. Now these are the values of zj. These are the values of zj. Here values are missing, so you can write it 0, 0, 0, 0, minus 1 and minus 1. So these values are here. Look at this. All values are greater than equal to 0. None of the value is negative. It means this is the optimal solution. But remember, this is phase 1 only. Phase 1 only means we are going to find the initial basic feasible solution only. ये जब आपको यहाँ मिल जाए तो इसका मतलब यहाँ पर आपको इनिशियल बेसिक फिजिबल सॉल्यूशन मिल रहा है. You are getting initial basic feasible solution. That is, what is the solution? X1 equal to 21 by 3. This solution is X1 equal to 21 by 13 and X2 equal to 10 by 13. जो कि हमें पहले ही जब आप ऑर्डिनरी सिंप्लेक्स मेथड करते थे, जो आपको पहले ही स्टेज में जब आप x1 इक्वल टू 0, x2 इक्वल टू 0 रखते थे, जहां हमें जो सॉल्यूशन मिलता था वही अब यहाँ पर हमें इस फॉर्म में मिल रहा है. So we have to consider this as the initial basic feasible solution. लेकिन ध्यान दीजिएगा, यदि यहाँ पर इन केस इफ सपोज आर्टिफिशियल वेरिएबल इज देयर विद पॉजिटिव वैल्यू, अगर आर्टिफिशियल वेरिएबल पॉजिटिव वैल्यू के साथ में यहाँ पर है, विच कैन नॉट पॉसिबल, इनिशियल बेसिक सॉल्यूशन पर आर्टिफिशियल वेरिएबल नहीं हो सकता. इट मीन्स इफ आर्टिफिशियल वेरिएबल इज देयर विद अ पॉजिटिव वैल्यू, it means we cannot get initial basic feasible solution, and immediately we'll write the problem has no solution or no initial basic feasible solution. So यहाँ पर artificial variable positive value के साथ में नहीं होना चाहिए. I will discuss this in another examples. Okay, so here we are getting the initial basic feasible solution, and this solution is this one. So the work of phase 1 is completed, and we are getting the initial basic feasible solution. Now with the help of this solution, we will take this as initial basic feasible solution, and we will solve the original problem by assuming this as the initial basic feasible solution. X1, X2 are there, means in the initial problem we will see X1, X2, S1, S2 were there. So you can assume S1, you can write S1 equal to, because these are now basic variables, so S1 will be non-basic, S2 will be non-basic. And the objective function, remember the objective function was maximize z dash this equal to minus x1 minus x2. So for phase 2 the objective function will be the objective function of the original problem. So this is the objective function, this is the initial basic feasible solution. So start with this one, look at this, form the simplex table with these variables only. This is, look at this, coefficient of x1 minus 1, this is minus 1, 0, 0, s1, s2. Okay, now basic variables are x1, x2, values 21 by 3, 10 by 13, and this is the, look at this, all these values are we are taking from here, because when we are taking this initial solution the values are changed in this form. So from here to here, simply you have to copy all these values here, because these values are same. From here to here you can write from this point, not only from this point to this point, you can copy all these values here, because we are considering this solution. So assuming this as initial solution, proceed further. So calculate z dash. Here z dash is minus 31 by 13, and the value of zj, look at this, here I have calculated, this is 0, this is 0, means this is cb xb minus cj. So if you calculate you will get 0, 0, 6 by 13, 1 by 13. The first step we are getting all positive greater than equal to 0, non-negative values. It means this current solution is an optimum solution. If suppose in case one of the value is negative, then again you have to process the same, you have to follow the same process of the ordinary simplex method, then you have to go for the optimum solution. But here in the first step we are getting the optimum solution. So this is the optimum solution. So final solution is x1 equal to 21 by 13, x2 equal to 10 by 13, and look at this is z dash, maximize z dash equal to minus 31 by 13, 31 by 13, but we have to find z in the form of z. This is maximize z dash equal to minus 31 by 13, but we have to find the minimum z. This is minus z dash 31 by 30. So this is the solution. So remember, first phase is to find the initial basic feasible solution, and if you are getting artificial variable here with a positive value, it means no feasible solution, no initial basic feasible solution exists. In phase 2 you will utilize this initial basic feasible solution with the original problem, then you will solve as ordinary simplex method and you will get the solution. So I hope that you got the concept of two-phase method. Thank you.